All right, our very last lesson here in Unit 3, when we're talking about our systems of equations, we got one more day on word problems. So we set up all the different types on day 1. Yesterday we picked a couple of types to really dig into, set up, and solve. Today we're going to hit just the last few types to define our variables, set up the systems, and solve all the way to the end. So very similar to yesterday, but we're going to have some different types of equations going on today. So our warm-up for today is to just set up this system. You don't have to solve it, but just make sure that you're really getting in that good process of defining your variables and writing your equations. So pause your video and see if you can set up this system. All right, at a bake sale, Alexis bought 16 items for a total of $23.40. Cookies cost $1.20 each, and brownies cost $1.90 each. How many of each item did she buy? I'm wondering if this looks familiar to you. It's very similar to our warm-up from yesterday. So let's see. Alexis bought 16 items for a total of $23.40. So she's got cookies, I see, and she's got brownies. I see that I know the cost of each, but it's asking me how many of each did she buy. So I am going to have my variables stand for the number. So let's go like C equals the number of cookies. And let's say B equals the number of brownies. Now you could use X and Y if you want to, not a problem. Like I said in other videos, I kind of like to use letters that make sense as long as they don't look like numbers. Okay, so C is the number of cookies, B is the number of brownies. I see in my first sentence here, it says that she bought 16 items. So 16 items, this is talking about the total number, right? C is the number of cookies, B is the number of brownies. When I add them up, they have to equal 16 total, right? So C plus B equals 16. There's our first equation, and that dealt with the total number, right? Then after that, it says for a total of $23.40. So this is the total value, right? Or the total cost, or however you want to think about that. So this time I have to get the dollars involved. So it says that cookies cost $1.20 each. So I'll have $1.20 times the number of cookies, plus brownies cost $1.90 each. So I'll have $1.90 times the number of brownies, B, and total, that is supposed to be $23.40. So my top equation is dealing with number of cookies plus number of brownies equals total number. The bottom equation is talking about total value. Cost of a cookie times the number of cookies plus cost of a brownie times the number of brownies is the total cost, $23.40. All right, so it says we just had to set it up. We do not have to solve, so we're good to go on that one. Hopefully you are getting in the habit of solving now, and it shouldn't be a big deal even if you did solve it. All right, so let's get into our actual ones for today where we're going to set them up and solve them. Number 1, the sum of two numbers is 16. The larger of the two numbers is 1 more than 4 times the smaller number. What are the numbers? Okay, so I'm talking about two numbers in this one, right? But later on then it talks about the larger number and the smaller number. So that's how I'm going to define my variable. So I'm going to say X equals the larger number, and we're going to say that Y equals the smaller number. All right. The first sentence says that the sum of these two numbers is 16. So when I add these two numbers together, it's going to equal 16. So X plus Y equals 16. Okay. There we go. All right, now the second sentence, the larger of the two numbers is. The larger of the two numbers. So the larger was X. So X is. 1 more than 4 times the smaller. And the smaller number we said was y. So the larger number, x, is equals 1 more than is 1 plus 4 times the smaller we said was y. 4 times y. All right, there's our system of equations. We got it set up. Our two sentences gave us two different equations. Now we need to solve. Hopefully when you look at this, you're like, oh, that's going to be substitution. I have an x equals, so I'm going to take whatever x equals there, which is 1 plus 4y, and I'm going to plug it in for x in the top equation. So it's going to become 1 plus 4y plus y equals 16. I'm just plugging in the 1 plus 4y in for x in the top equation. Now you could put it in parentheses. We distribute the 1 and it would become exactly the same thing. Since it's at the very beginning of the equation and there's nothing I'm multiplying by, no negative sign or anything like that, you don't technically need the parentheses in this spot. But you could put them in if it makes you feel better. Just make sure you distribute and then you end up in the same place. All right, so now I'm going to combine my like terms. I have 1 plus 5y equals 16. I'm going to subtract 1 from both sides. I get 5y equals 15. I'm going to divide both sides by 5, and I get y equals 3. So the smaller number is 3. And now I'm going to solve for the larger number. So again, I'm going to take this bottom equation. Technically, you can pick either equation, but this one is all set up nice for me. So x equals 1 plus 4 times 3. So I get x equals 1 plus 12. So x equals 13. So my two numbers are 13 and 3. And x was larger and y was smaller, so I know that it makes sense. Since these are just numbers, there isn't really a label for these. So 13 and 3 are just the two answers. You could say larger number is 13, smaller number is 3, but that's pretty obvious just by looking at your two numbers, right? So knowing that x is the larger and y is the smaller is just a good way to check and make sure nothing went wrong as you were solving, that x is really bigger than y, and then it will all make sense. All right, first one is done. Hopefully those two number problems are not too difficult for you. All right, number 2, the length of a rectangle is 4 inches more than 3 times the width. The perimeter is 72. Find the width and the length. So we did set up one just like this on that first day. Again, we talked about how sometimes drawing the picture helps your brain recognize what's going on. If we label our picture with our variables, that is good enough for defining them. So I'm going to say length is going to be L, and I have two lengths in my picture. Width is going to be W, and I have two widths in my picture, so I'm going to make sure that I label both of them. So L is length, W is width. All right. In the first sentence here, it says the length of a rectangle, so the length, this was L, is 4 inches more than 3 times the width. The width was W. So the length is, so L equals 4 inches more than, so 4 plus 3 times the width, so 3W. So there's my first equation. L equals 4 plus 3W. My second sentence says that the perimeter is 72. Perimeter equals 72. So my perimeter means that I have two lengths, right? I add them all up. W plus L plus W plus L. So, or 2L plus 2Ws equals 72. So 2L plus 2W equals 72. Now I have my system and I'm ready to roll. And again, on this one, it is set up perfectly for substitution, right? The top says L equals. So I'm going to take what L equals, 4 plus 3W, and I'm going to plug it in for L in my bottom equation. So this is going to say 2 parentheses 4 plus 3W plus 2W equals 72. All right, now I'm going to distribute. So I have 8 plus 6W plus 2W equals 72. I'm going to combine my like terms, so I have 8 plus 8W equals 72. Subtract 8 on both sides. I have 8W equals 64. And now I divide both sides by 8, and I get W equals 8. So my width equals 8, what are we talking about? Inches. So again, being very clear when we are labeling our answers, we don't just label it the units, inches, which we have to, but we also say which one it is. The width is 8 inches. All right, and now I'm going to take that 8 and I'm going to plug it back in. You can plug it into either equation, but I see that top equation is all set up for us. So it's going to be L equals, there we go, L equals 4 plus 3 times 8. So I get L equals 4 plus 24. So L equals 28. So my length equals 28 inches. Being very clear about our labeling of our answers here. Which one is the width, which one is the length, and also making sure that I have the units. All right, so we did practice setting those up earlier in the chapter, and so now all we're adding on is just the solving, so hopefully you're feeling confident in these. Last one that we're going to tackle, we've got some complementary or supplementary angles, and again, we are going to make sure that we use a system to do this. Back in Unit 1, we talked about how to do this problem with only one variable, which you can do, but not in this unit. I want to show you this other method to do them after Unit 3. Then you can pick whichever method you like better and use that whenever you solve these problems. But for right now, I really want you to use a system to solve this problem so you can practice and get better and see this method. All right, so number 3 says 2 angles are supplementary. The sum of the larger angle and 4 times the smaller angle is 261. What is the measure of each angle? So again, I see that we're talking about 2 angles. Later on though, we talk about a larger angle and a smaller angle. So that's how I'm going to define my variables. So I'll say x equals the larger angle. I don't know why that's there. Okay, sorry about that. Technical difficulties, here we go. All right, x equals the larger angle, y equals the smaller angle. All right, and it says that these 2 angles are supplementary. So remember that supplementary means that they add up to 180 degrees. So the larger angle plus the smaller angle equals 180 degrees. Okay. Now the second equation says the sum, so I'm adding something together. The sum of the larger angle, so that was x, and 4 times the smaller, which we said was y, is 261. So equals 261. So x plus 4y equals 261. The sum of the larger and 4 times the smaller is 261. So you have to know which variable stands for which here. All right, we've got our system all set up, and on this one I can choose substitution or elimination. Now I've done substitution on the last two problems, so I think I'll choose elimination on this one, but again, you could do either method. This one is set up perfectly for both. And technically I could eliminate both either the x's or the y's on this one in a very easy one-step process. I think I'm going to eliminate the x's because all I need to do is multiply that top equation by -1 and I will have it, and that's easy math to do. So let's see, the top equation will become -x minus y equals -180. The bottom equation is staying exactly the same. X plus 4y equals 261. All right. I am ready for elimination because I have opposites in my x's, so I add my equations together. Those x's eliminate. -x plus x cancel out. -y plus 4y gives me 3y. -180 plus 261 gives me 81. All right. Now I am going to divide both sides by 3. And I get y equals 27. So the smaller angle will be 27 degrees. Remember, we are labeling this one, and the measure of an angle is in degrees. All right, now I can pick either equation to plug back into to solve for x. The top equation does seem to look a little bit easier, though, so I think I'm going to choose that one. So we're going to plug into the top equation x plus 27 equals 180. And then I will just subtract 27 on both sides. So I get x equals 153. So I have 153 degrees for my larger angle and 27 degrees for my smaller angle. And again, it's not so important that you label which one is the larger and which one is the smaller. You can tell that just by looking at the numbers, but it does help you when you're writing the equation, and it also helps you just make sure that your answers make sense, that you didn't get a bigger number for y than you got for x, because then something probably went wrong. But do make sure that you label those with degrees. All right, guys, I think we have now tackled all the different types of problems that we saw on that first day, and probably even more. So just don't forget to define your variables and be specific, right? Are you talking about the number? Are you talking about the dollars? Are you talking about the larger or the smaller, right? So be specific when defining your variables. If you need to, think about, is your equation representing total value or total number? And then make sure that you label your answers clearly whenever that makes sense. The only time you don't have to label your answers is when you're just talking about two numbers. Otherwise, you always need to label. All right, good luck with those word problems.